Welcome back. In this module, I'm going to give an overview of the labs contained in the MIPSfpga Labs Packet. This lab packet contains hands-on learning in the areas of system-on-chip design, assembly language and C programming, instruction set architectures, hardware description languages, computer architecture, memory systems, memory mapped I/O, interrupts, and performance counters. We've organized them into 4 main sections: the introductory labs, labs 1 through 4, the I/O labs, labs 5 through 13, labs focusing on the core, 14 through 19, and finally, we have labs on the memory system, including the caches. So here's a list of all of the labs. Introductory labs include creating a Vivado project and some programming labs. The I/O labs show how to interface with various peripherals, as well as showing how to use performance counters and interrupts. Part 3, the labs focusing on the core, show how to understand the MIPSfpga pipeline, how to trace an instruction through that pipeline, and how to modify the core and system to accommodate new instructions. The last section, part 4, focuses on caching, the cache structure, and also shows how to use a scratchpad RAM. Let's go ahead and open the labs package and take a look at its organization. The labs package provides an overview document that shows how to use the labs and what kind of hardware is needed. And then we can click on the labs directory and Xilinx, and we can see all of the different parts, part 1, 2, 3, and 4 of the labs package. If we click into those directories, we can see each of the labs. Each lab has some supporting documentation and possibly supporting files as well. Also important to note is that there's a solutions folder also organized into each of the parts. You can click into those locations and see the solutions for that lab, which can include Verilog files and software as well. I've already demonstrated some of these labs, creating a Vivado project, Lab 1, Labs 2 and 3, C and assembly language programming. And in future modules, I'm going to show how to use some of the peripheral interfaces, some of the labs relating to the core, and the memory system.